Hi there, it's a long time since I've done a video because I've been engrossed in this problem that has taken me a long time to solve. I'm sure lots of people have done it, but I can't find an easy solution. The basic idea is that I have a motor which drives a linear device, a rack, and that it should go out, delay, and then come back again. I don't include the delay in this video, that's for another one. This is just basically an introduction to relays and using relays to control small toy motors. So if I press my button, my carriage goes across, hits the switch here and then goes back again. Not exactly revolutionary, but that's where the end of the video is, and that's where I'm heading with this video. So I'm going to go right down to basics, right start off, and see where I can go and what a relay is and why it works and how it works. So let's start off by having a look at an electric motor. Here we've got an electric motor, a toy motor that, if I can put the switch on here, is just the sort of thing you'd find in any old toy. I've built a gearbox onto the top of it because basically these motors are far too fast to do much with, and they don't have the turning force, the torque as I believe they call it, something I've got a lot of. So if I put my motor into there, plug it in, and it goes in one direction. To get it to go in the opposite direction, we have to turn the plug round, and then it will go in the opposite direction. This is a bit tedious, so what we want to do is to find a method by which we can reverse the motor without having to physically turn over the contacts. To do that, then we can use a switch. This switch then is called a double pole, double throw switch. If we can get a close up, hopefully we can see it has got 6 terminals on the top. One side is what we call one throw, and one pole, and the other side is the other pole. They two sides aren't connected together, and in the middle I've connected the motor. To connect the switch then, I've connected one to positive, one this side, and positive at that side, 0 volts at this side and 0 volts at the top. Perhaps easier if we have a look at a little diagram. So here I have my diagram of the top of the switch showing me the 6 contacts. How does the switch work then? Well, if we want to know how it works, what we have inside essentially is just 2 pieces of metal. The 2 pieces of metal on this switch are either there so that the blue contact of the motor is to the 0 volts and the green contact is to plus volts. If we then slide the switch across, then now the blue is to the red and the green to the 0 volts, and that's all I'm doing. I can't switch the switch off, but it does keep going backwards and does keep going in the same direction. How could that be useful? Well, I have a little gizmo here that I built a few years ago that essentially uses one of these double pole double throw switches, or a changeover switch with its 6 connections on the bottom. But on this device then we have a lever or a rod connected to the switch, so that when the switch moves, the rod moves, or should I say that the rod can move the switch, so that when this unit here gets to the outside, pushes the switch that way, changes the direction, When it comes to the inside, it pushes it that way, changing the direction. So let's see if it's going to work. Must get it the right way round. And there it goes. Pushing against the rod at that end and the switch at that end, changing it backwards and forwards. But that isn't really what we're looking for, but it does show us an application of the switch. The problem with that switch, of course, was that you couldn't switch it off. So what we want then is a switch which is called a center off switch. So called because it's off in the center. So now the motor part here isn't connected to the positive or to the 0 volts. It is simply off. So if we plug it in and plug it in, then nothing happens because it's on the center position. If I move it to the left and knock the wire off, nothing happens. Move it to the left, it goes in one direction, and move it to the right, it goes in the opposite direction. So that's a center off switch, which allows us to stop in the middle. But we don't want to be getting into using switches really, do we? We want a switch which is automatic. And for automatic switches then we turn to a device called a relay. The relay then, essentially all we have is a coil of wire and a lump of steel up at the top. We know it's steel because if we can find one, ferrous I should say rather than steel, but it does, a magnet does stick to it. So it is magnetic even though it just looks to be a copper colour. Presumably it's covered in copper to protect it from rusting. It's actually out of a car alarm system, so it's thank you to Richard who gave it to me. And the problem with it is it's 12 volts, so I need to be careful to use it. And what happens with it, well, we have this piece of steel, as I say, at the top, and when that's attracted to the magnet, or the coil becomes a magnet, it's attracted to it, then that moves down, and that there then, where have we gone, makes contact with the bottom contact, and when it goes back up it contacts with that. There's just a spring on the back to pull it so that it comes down at the back and goes up at the front. If we try it, hopefully we can see it working. Doesn't really matter which way round this is. So you can see there's off and there's on, and that's going backwards and forwards as the coil becomes a magnet like there and loses its magnetism like there. But this isn't much use to us. Must be careful with this 12 volts not to start using that. Get rid of that. That's not much use to us. What we want is a relay that is like our switch, a double pole, double throw. So here we have a double pole relay. In other words, it's got two sets of contacts on it, and they are double throw because normally they're down at the bottom and then they come up to the top. A bit more complicated than the 12 volt relay, in as much as the coil is horizontal and the thing that's attracted is at this end, and that then moves the arm up and down, changing the contacts over. Right, a very nice little gizmo. Normally it would be in a plastic case, of course, to protect it, but what the heck. So let's have a look at our diagram. If we look at the diagram, then we've still got our switch type thing, but instead of drawing it the way I did, I've drawn it slightly different. What I have is the two changeover parts. So we can see the blue part of the motor is to positive and the green part of the motor to negative, so it goes in one direction. When I energise the relay, it goes in the opposite direction with the green to positive and the blue to 0 volts, or negative 0 volts anyway. So that's how it's working. We need to draw in the coil, so let's draw in our coil. So there's my coil, and that then is sort of here, and when I press the button it energizes the coil, which changes the motor direction. So let's have a go at that. Let's see if we can get that to work with our relay here. So we need to plug in our motor. Plug the motor in, that's the motor in place. And then we need to connect the power, making sure it's not the 12 volts. And wow, the motor power's come off again. Try it again. So there, the motor's going, the relay is not energized, so the motor keeps going in one direction. When I press the button, we can hopefully see the arm going up, and the motor goes in the opposite direction. Yeah, could play with it all day, love that type of thing anyway. So that's our double pole, double throw relay with its coil of wire. But that isn't any good because once again I keep having to switch it on and off, and I want the thing to be automatic. So how can I make it automatic? One way to do that, one way is to use a relay which has got three something on it. So how does that work? Well, we have 3 sets of contacts. Instead of just the 2, we have the 3. So we've added this 3rd contact here. Now, how does this work? Well, if it was connected up there, get it in the right place there, what happens is I press the button down at the bottom of the relay, and that then energizes the relay. When it energizes the relay, the contact comes across. So this contact comes across, makes contact, and therefore the relay is energized through the contact. So as soon as I let go of the button, the relay stays energized. That would be brilliant, apart from how do we stop it? Once it's energized, I can't stop it. I need to stop it some way, and the way to do that is to put a normally closed switch in here. So we put a normally closed switch in there, and that then once this relay is energized, and that switch, it stays energized until that switch is opened. Now when that switch is opened, there's no circuit for the relay, so the relay drops out and the motor goes in the opposite direction. The problem is that when it gets to the other end, as it is here, then it'll keep going and won't stop. So what we do is to put another normally closed switch in here, so that when the motor gets to the end, this switch opens. There's now no circuit for it to go, and therefore the motor stops. Why does it restart? Well, it restarts because when we press the button and energize the relay, the blue contact, instead of being to positive, is to negative, and the green contact is to positive, but the switch isn't stopping the current getting to there. So therefore the switch then, the motor starts moving out, or the carriage starts moving out, until it hits this normally out switch. When this opens, and it goes back in again and touches its normally closed switch. So yeah, that's the way that I've done it so far. Not a way to be recommended because it actually needs a 3-pole relay, and we can get away doing it simpler. But the whole of this video was just to explain an introduction to relays and how they can be used. So yeah, this is my system. We saw it at the beginning, and this then works, but it doesn't stay out at the end, and the whole of my dilemma is to get it so it stops when it's out for a few seconds and then goes back in again. And that can be done without the 3-pole relay. So I'll do that in my next video. So it's bye now. Bye.